All right, let's go ahead and take a look at the next topic, which is rewrite logarithmic expressions using properties. So we're going to use the properties that we learned in the previous section. Remember, we have expanded. Now we're going to expand and condense. We're going to expand, we're going to condense, and we're going to use change of base formula. Let's go ahead and take a look at the first problem. They're asking us to expand the logarithm. So I'm going to go ahead, zoom in here. And first I'm going to identify what operations do I have. There is a multiplication here. I see a division here. I see a power here. And I also see a power here. Do you see what I see? Now let's go ahead and start with the division. So the division now becomes subtraction. So it becomes subtraction. Log. Base b, base b. Numerator goes on the top, denominator goes in the bottom. Okay, once that's done, I see a multiplication. Multiplication now becomes addition. Log, base b, x cube, y, and now this one stays the way it is. Log z squared base b. I'm not done yet because I do have my powers here. What do? The powers get kicked right up in the front. So now this is going to be 3 log x base b plus log y base b minus 2 log z base b. So you should always tackle your powers all the way in the end. And if you look closely, first step is to identify your operations and then use the required functions. All right, now let's go ahead and take a look at the next one. Here, what do I have? I have log, I have a division, right? I have a division. That becomes subtraction. That's all I have. So minus, this is log radical 6 base 6 minus log 36 base 6. Now, am I done? No, you can go ahead and simplify this further. Now in my mind, I'm asking, to what power should I raise 6 to give me radical 6? To the power half. You can plug this in decimals and see you will get a half. Minus, to what power should I raise my 6 to give me 36? 2. So my answer is negative 1.5 because half minus 2 is 1.5. And that is your final answer. Now let's go ahead and take a look at the next one. Step 1 is to identify. I have a power, I have a power, I have a power, I have a multiplication, and I have a division. So I'm going to start with my division. Minus log. Looks like I need more space here, so I'm going to move this to the side. And this is going to be 5th root of x times y power 4 minus z power 7. The base is 2, the base is 2. Now let's zoom in. I do identify another operation, which is multiplication. So single log becomes double log. The bases stay the same. Y power 4, 5th root of x minus log z 7 base 2. I still see a power, and a power. What do? Powers go right up in the front. Remember, I cannot write radical 5. I have to write it in terms of a fraction. So radical 5 in terms of a fraction is 1 over 5 log x base 2 plus 4 log y base 2 minus 7 log z base 2. So your powers should always get kicked right up in the front. Okay? All right, now let's go ahead and take a look at the next one, which is change of base. So what I'm doing here is, let me expand this one. I have log m to the base b. So what I'm doing is, I am using a common base n, and I'm dividing log m with log b. Now, you must say, Miss, I don't understand what that means. So let me show you what that means. Log 2 to the base 5. So if I have to find log 2 to the base 5, what I can do is I can change the base. I'm going to say log 2 to the base 10 or log 5 to the base 10. Or, to keep it simple, I can use ln 2, which is base e, or ln 5. So I'm changing the base and I'm calculating it. So let's go ahead and use the properties of logs to condense as much as possible. So what am I doing here? I am adding. Addition now becomes multiplication. So this is log 250 times 4. I don't see the base. The base is automatically a 10. 250 times 4 is 1, 0, 0, 0, base 10. I don't have to put a base 10, remember, but you should always see a base 10. Log 1000 base 10 is, oh, never mind, it's 3. That's your final answer. Now let's go ahead and take a look at the next one. We are condensing the logs. Remember, they ask you to condense the logs. In the previous case, you were expanding the logs. In this case, you are bringing them together. So this multiple logs now become single log. So you're going backward. So I do have a subtraction. Remember, subtraction is nothing but division. The first one is the numerator. The second one is the denominator, and all I have to do is put a log. If I don't see the base is 10, but I don't have to put base 10. It's automatically understood. All right. Again, pause if you have questions and rewind it, play it back, but make sure you understand. Now let's go ahead and condense it. I'm making this a smaller and I'm making this into a single log. To start with, remember what we did in the previous one. We worked with the powers in the end, but now you have to work with the powers in the beginning. What does that mean? I'm going to go ahead, put a power. Go ahead, put a power. So this becomes log x. You know what? Let's try this one. This becomes much easier. Let me do this one. Just because I have a parentheses here, as you can see, log x minus log y, because I have a parentheses here, let me go ahead and combine these first. So half stays half. Subtraction now becomes division. The numerator is the first one, denominator is the second one, and I have a base 5. Do you see that? Plus 3 log x minus 1. This is single log and subtraction, so this does not become log x over log 1. No, it does not become that because it's single log. That one only becomes double log when it's subtraction of 2 logs. I hope that's more clear. I need to have, remember how you have here? You have log of x minus log of y. That's only when it becomes log of x over y. This is log of this whole number, so you cannot separate this one. Make sure that's very, very clear. And once that's done, I know this is my power. This is my power. So what happens? The power goes right up on the top, right up on the top. So this is log. To the power half is what? Square root of xy. Half is square root, remember. And log x minus 1 cube. Oh, I forgot the base 5. And now do I see an addition? Addition of log becomes addition of double logs becomes multiplication and single log. So this now becomes log base 5. This is radical x over y times x minus 1 cube. So double log becomes single log, addition becomes multiplication. Again, pause and see if you understand, and then move forward. All right, now let's go ahead and find out the next one. This is change of base formula. Use natural logs. Now you can definitely go ahead and plug this into your Desmos and you'll see what you get, but let's go ahead and change that into a natural log. Natural log is to the base e, remember? And the change of base formula, what do? This is log 320 over log 7. Both of them are to the base e. But when they are to the base e, I don't write log to the base e. What do I write? ln. ln automatically means log to the base e. Now let's go ahead and see if these are the same. I'm going to go ahead to my Desmos. And here I am going to, let me see if I can zoom this in. No, I cannot. Oh yeah, I can. I'm going to go ahead to my calculus and I'm going to find log 320. Oops, that was base 7 and this was 320. And now when I changed it to ln, where is my ln? ln 320 over, I think I can put ln here, ln, I forgot the division sign. Divide ln 7. And if you can see, both of them are exactly the same. That's how change of base formula works. I want you to go ahead, plug this into your Desmos to see if that works. Oops, what was that? I forgot. 2.9643. So this is nothing but 2.9643. They say round off to 4 decimals. Yep, we are good. All right. Okay, let's try the next one. I don't think I have to try this one, but let's go ahead and do it. Log, common log is to the base 10. So log 27 over log 9. Let's go ahead and plug that in. log 27 divided by log 9, 1.5.